So that means we should comparing the both the values. So whenever the Qn is changed to the Qn plus 1 or not. So that means here Qn value will be 0 and Qn plus 1 value will be again 0. So that means present state output and the next state output will be same. So here the both the values will be doesn't change. So that means from one state to another state the value doesn't change here. So directly we can say that no change output we are collecting. So in truth table no change where we are getting in the input path. So that input path will be considered as 0. So that means no change output we are collecting in 0 input path. So now coming to the comparing second case, 0 to 1. So 0 to 1 is nothing but just comparing whether it is changed or not. So 0 to 1 is nothing but it's changed, right? So that means exactly opposite value we are getting. So that is nothing but complement case we are getting. So toggle condition is nothing but what? So that is complement case. So here also the complement condition is raised. So that's why this t input we can consider as the 1. So like this in third case. So 1 is compared to the 0. So 1 value can changes to the 0. That means again the both the values will be different. So that means complement condition is raised. So then we may get the input t as 1. So now coming to the last case, 1 compared to 1. So then both the values will be same. Here it doesn't change from one state to another state. So there is no change at all here. So no change operation we are collecting from this. That no change operation we are comparing to the truth table. So whenever we t input as 0, we are getting the output as no change. So then, so this output input will be 0. So then the truth table excitation table of the T flip flop is 0 1 1 0. So that means excitation table is nothing but exactly reverse of truth table. So here outputs will be considered as inputs and inputs will be considered as outputs. So that is the logic behind in that excitation table. So these are the 4 flip flops of the excitation table, T and JK, D flip flop, and also we are having SR flip flop. Okay, so remember this one. This all SR all flip flops of the excitation tables will help to write the or will help to design the clocked sequential circuit. So that concept will discussed in later. That's very important for long answer analysis concept and design procedure concept of clocked sequential circuit. Okay, in analysis procedure we don't use this excitation tables, but coming to design procedure we need to use the all the excitation tables of all the flip flops. Okay, so while designing any of clocked sequential circuit compulsory we need to use of the this excitation tables. Okay, you must learn the all flip flops of the excitation tables.